Welcome to this LeetCode video where I'm going to go through two solutions to LeetCode number 1156, swap for longest repeated character substring. So I'm just going to explain what the question is first. So we're given a string called text, and in this string we can swap two of the characters. And so we want to return the length of the longest substring with repeated characters. So what that pretty much means, it's not explained very well, but we want to return the longest possible length of repeated characters in text that we can get after swapping two characters in text. So these examples are pretty simple. We've got example 1 when text is AB, AB, A. If we can swap the first B with the last A, or the last B with the first A, and that will give us either 3 A's in a row at the start or 3 A's in a row at the end. So we'd return 3 there. In example 2, when we've got this string with 3 A's followed by a B followed by 3 A's, we can output 6, as we could swap B with either the A at the start or the A at the end, which would result in a 6 character long substring of repeated A's. In example 3, where it's all A's, we don't have to swap anything, so we can just return 5, as there's already 5 consecutive A's there. And so the constraints for this question, so text length can be between 1 and 2 times 10 to the power of 4. So for an acceptable solution, I think we're looking at around something with a time complexity of big O of n squared, no worse than that, I would assume there. And text consists of lowercase English characters only. You might think that's not really needed at the moment, but for our optimal solution, which we will look at in a minute, we can actually use that constraint to greatly improve our solution. So when I first attempted this problem today, I didn't get the optimal solution the first time around, but this was the first sort of naive approach I had. So my first idea was to find the longest substring that had repeating characters except at most one mismatching character, and I just did that using a sliding window technique, and I'll just go through this code as well. And then after that, what I did was, for the longest substrings with repeated characters except at most one, I would also check the rest of the text string if there were any characters I could use to increase this substring by 1, as in to swap the mismatched one, and then that would give me the answer. Now, at first that sounds like a pretty simple idea, but I found that while I was coding that it was actually quite tricky. So for that approach, I initialized my pointers at the start. I kept track of the max length. I also had to create a vector of pairs just to keep the pairs of pointers that pointed at the max substrings with repeated characters except at most one, just because we can't just take one of the maximum ones, because what if we don't have another character to swap into that one, but maybe a tied substring, we could swap it, we wouldn't find that one. So I had to use pairs I chose. Anyway, so we initialize our pointers at 0, 0 and our max pointers at 0, 0, 2. And we also need to keep track of the position of the first mismatch we did, because what I decided to do was to start both pointers from the start and just increment the right pointer. Once we find our first mismatch, we mark the position and just mark that we have found a mismatch using this Boolean variable. And then we can go and find, once we get to the second mismatch, then we would stop, and that would be our substring, not including the second mismatch, that is. I also had to just push back an arbitrary character just in cases where there would be no second mismatch, sorry. And I mean, that was just sort of a hard-coded workaround, not the best practice. But so for our sliding window, we just do a while r is less than text size, so while we're not at the end yet. if the next element of text after R is equal to text L, then we just increment R because text, the character at L in text is the sort of the character we're trying to match. So in this case, we're looking for more A's as we start at the A. Else, if the next character does not equal text, but we haven't found a mismatch before this, then we're allowed one mismatch. So we still increment R, we set mismatch found to true, and we also update our first mismatch position, which we will use a bit later on to move our window to the next iteration. Else, once we find our second mismatch, we must update our max length, so the max sized window that we found, and we also want to update our max pointers, and we also want to push back max pointers to the vector. Now looking at this again, I think it might be necessary to clear if it's more, but I mean in the test cases it worked for all of them, so it might be wrong. If anyone in the comments has any ideas, if you think you might need to clear the max pointers, I actually think that might be the reason for one of my errors I found. I think that's a mistake, but it works for the test case. I think I coded some extra things in at the end that just fixed that mistake, but I'll go through that and explain what that was. This was just my first attempt. So yeah, we update the maxes, and then we also want to reset the variables for the next window. So we just set mismatch found to false again, and now we want to start our left and right pointers from the first mismatch position that we found earlier. So in this case, we've started at A, we're looking at B, we look at A, we see the next one is B, so we don't consider that one. We have our A, B, A, so we set max length to 3, we set max pointers at the moment to 0 and 2, and we also push back those pointers to the max pointers vector. And then after that, we want to do the same thing starting from B, as it was our first mismatch. And we go there to the A and then to the B again, and then we can't go to the A there, so we don't do it. We have 3 again, the same sort of thing, and then we start again from A and do the same thing, and so on. So it's not super efficient, but it worked, which is always good. And then after that, also if we've never found a second mismatch, so if we've gotten to the end and remember about the capital A we pushed back, that would be the first mismatch. If we never find a second mismatch, we would only ever go through this if condition, and then we would end up not even considering these, which is just why this pushback operation is there. Looking through this again, this is very inefficient code, but this is just my first approach. We'll go through the optimal solution just after this one. So now what we want to do is, using all of those max pointers, those max sized windows, is we just want to look to the left side and the right side of the window in text and see if there's any characters in there that we can swap with the mismatched character to give us a max length of +1. Otherwise we would just return the max one. So all we do for that is just iterate through the max pointers, and we just set the pointers to be the first and second, which is just setting our window, and then we just go through 2 different for loops to the left of the window and to the right of the window, and if we ever come across a character that's equal to text L, which is the letter we're looking for to swap our mismatch character with, we just set our max length to the, we just update our max length. Now, if I think if I cleared the max pointers vector here, every time we found a length that was more than max length and not just equal, we could just return the max length there. I think I've overlooked that. But just here we just update our max length and set the max to the max length and also the length of the current substring, and that +1 is just the taking into consideration the swapped letter, and the exact same thing for the right side, just from looping from R+1 to text size. And if no swaps can be made, then we would end up getting to this update, where we'll just update max L to max L, or take L, no +1 there, and then we just return max L, and that gives us a solution which works. If I'm correct, that's about big O n squared time. If I'm correct there, just by the window that we slide here. So it's not great, but it works and actually beats 70% of users with the runtime around there apparently, and doesn't use too much memory either. Now we will go through the actual optimal solution. This one here is much more simple, and if I recall correctly, it only takes big O of n time and looks like big O of n space, as far as I'm aware. So in this solution, we want to create a vector of vectors to store the indices of each character in the text, just called character indices here, and it has 26 because it's from A to Z. And to do this, we just loop through text and add the index there, I, to the corresponding character vector in character indices, which we can get just by text I take A, which will give us sort of a mapping from 0 to 25, where A is 0 and 1 is B, Z is 25, etc., everything in between. And now what we want to do is just iterate through each character A to Z, just in this loop here. And we want to also initialize some variables to track the current counts and the consecutive counts and the max length that we found. So we iterate through each index of the current character, just in this for loop, and we check if the current index is consecutive to the previous index, as in, is the current index I there the same as the previous I plus 1. If it is, we just increment our count for our consecutive characters count. Else, we want to update consecutive count and reset the current count. And to update the consecutive count, we just check, does the ith element of character indices, is that equal to the previous one plus 2, as in, is there just one gap between them? If there is, we just update consecutive count to current count there. Otherwise, we reset it completely to 0. And of course, yeah, we reset current count to 1. And then after that, we update our max substring length seen so far, just in here, by doing max what we've seen, and then the consecutive count plus the current count. And we just go through that for each index of the current character. And then we update the result with the max substring length for the current character. So we just have a result equals the max of the result and the max substring length plus if the character indices number of elements is more than the max substring length, we plus 1, which just means that if we've got some more characters that aren't in the max substring, we can swap one in. So that would mean plus 1. Otherwise, if there's no more to choose from, we just plus 0 because we can't swap anything in. And we just do that for each character just in case. And then after all that, we return the result. And so if we submit that, we can see how that performs. And it actually beats 100% of users with C++ in the runtime. Unfortunately, it uses big O of n memory, as we have to keep track of the character indices. I think takes up the brute, the main part of the memory there. Hopefully that made sense and was easy to understand. If you need anything to be cleared up, just leave a comment down below and I'll be sure to get that in, I don't know, at most 2 or 3 days, I can probably say. Yeah, if you enjoyed this video and you'd like to see more things like this, be sure to leave a like, subscribe, comment any feedback you have. It really helps and it really lets me know to keep doing this stuff. Alright, thanks for watching.